Okay, there's the title of the video. And it's part 284C3m1b7a15. And this is line 22f1fa19c3m1b7a15. Non-Perturbative Lepton Nuclear Kondo Effect 5G Wow Seti. So there's the alien radio signal. This is a research in PDF keywords. So that's what it's about. November 27th, the keywords research continues. Today is December 12th, 2012. So I'm going to quote a PDF file, non-perturbative nature of the effect. So I googled that, and this is what came up. Nature of non-perturbative effects in Lepton Nucleon scattering. And that's from Michael Barnett, Stanford University, California, 1982-83, okay? So there is evidence for substantial non-perturbative effects in the structure functions extracted from deep inelastic lepton nucleon scattering. These effects have a major impact on AS and A determinations, or it's not A, sorry, that symbol there. Results which I reported previously for I'm going to say UN and VN, even though that's not correct. Scattering F2 and XF3 are extended to include ED data, which are at lower W2 and higher X and have extremely high statistics. Sorry, I can't talk today. Possible analytical forms for higher twist terms and for A5 are considered in detail here, using that symbol there and ED data. Because in 1983, that's link.aps.org, okay, and prd.aps.org. So quote another PDF file, non-perturbative Euler-Heisenberg, Lagrangian, and Paraelectricity and Magnetized Massless QED. That's from April 2012, so this is pretty new. There's the people that worked on it. In this paper, we calculate the non-perturbative Euler-Heisenberg Lagrangian for massless QED in a strong magnetic field, where the breaking of the chiral symmetry is dynamically catalyzed by the external magnetic field via the formation of an electro-positron condensate. This chiral condensate leads to the generation of dynamical parameters that have to be found as solutions of non-perturbative Schwinger-Dyson equations. Since the electron-positron pairing mechanism leading to the breaking of the chiral symmetry is mainly dominated by the contributions from the infrared region of momenta much smaller than the magnetic field, introduces a dynamical ultraviolet cutoff in the theory that also enters in the non-perturbative Euler-Heisenberg action. Using this action, we show that the system exhibits a significant paraelectricity in the direction parallel to the magnetic field. The non-perturbative nature of this effect is reflected in the non-analytic dependence of the obtained electric susceptibility on the fine structure constant. The strong paraelectricity in the field direction is linked to the orientation of the electric dipole moments of the pairs that form the chiral condensate. The large electric susceptibility can be used to detect the realization of the magnetic catalyst of chiral symmetry breaking in physical systems. Okay, so that's high energy physics, rxiv.org. Okay, there's a link there. November 27th. My thoughts. Most of the keywords keep bringing up ways and means of creating a magnetic and electric force in different experiments. So the keyword to Google is paraelectricity in the next video. So that'll be covered in another one of the videos, okay? So I'm going to quote another PDF research article on non-perturbative techniques for thermal radiation effect on natural convection past a vertical plate embedded in a saturated porous medium. It's from Belleville, South Africa. See how these things all come from all over the world? That's so cool, right? 2008, 2009. Moseki, this is an open access article, blah, 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 blah. Okay, so in this article, the heat transfer characteristics of natural convection about a vertical, permeable, flat surface embedded in a saturated porous medium are studied by taking into account the thermal radiation effect. The plate is assumed to have a power law temperature distribution. Similarity variables are employed in order to transform the governing partial differential equations into a nonlinear, there's nonlinear again, ordinary differential equation. Both Atomian decomposition method, ADM, and His variational Arterian method, VIM, coupled with Pade approximation technique, are implemented to solve the reduced system. Comparisons with previously published works are performed, and excellent agreement between the results is obtained. And that's from www.hindawi.com. Okay, there's the link there. November 27, my thoughts. We were talking about plates before in another video and how to transfer power using X-rays and laser beams. This technology will be added with the other WOW formulas and ideas for the space elevator and the UFO spaceship. So the keyword Kondo effect, quotes from Wiki. In physics, the Kondo effect describes the scattering of conduction electrons in a metal due to magnetic impurities. It is a measure of how electrical resistivity changes with temperature. So we have high T weak coupling, low T strong coupling. So impurity spin, conduction, electron spin, and then you have non-magnetic state. Okay? Schematic of the weakly coupled high temperature situation in which the magnetic moments of conduction electrons in the metal host pass by the impurity magnetic moment at speeds of Vf, the Fermi velocity, experiencing only a mild antiferromagnetic correlation in the vicinity of the impurity. In contrast, as the temperature tends to zero, the impurity magnetic moment and one conduction electron moment bind very strongly to form an overall non-magnetic state. November 27th, my thoughts. This diagram of the weakly coupled high temperature situation gives us an idea how to create a magnetic or non-magnetic state in the particles used for the space elevator UFO spaceship idea. This will have to be added to the previous formulas found in the WOW videos. See more keywords in the next research video. Thanks for watching.